Question 1 is looking at the displacement of water in a harbour, and the first part of the question asks you to describe the difference between displacement and amplitude. So displacement is the distance from the equilibrium position, but the amplitude is the maximum displacement. The second part asks you the difference between frequency and angular frequency. Now we know that frequency is the number of oscillations per second. But what's angular frequency? Angular frequency is actually a definition, and it's defined as 2 pi f. So part B goes on to ask about this harbour and the oscillations of the water caused by the tide. And it gives you some numbers. It gives you the time period, and it gives you the maximum and minimum depth of the water. And the first part that it asks you is to work out the amplitude. Well, the maximum height of the water is 18 metres and the minimum is 13 metres. But that's the whole difference between the lowest level and the highest level. So we need to divide it by 2 to find the amplitude, as the amplitude is the distance from the middle to the top or the middle to the bottom. So its minimum level is 13 and its maximum is 18. So to define the amplitude, we look at half the difference between them. And this gives us a value of 2.5 metres. The second part asks you the frequency. The frequency is 1 over the time period, and we know that the time period is 12.5 hours, but we need this in seconds. So this is 1 over 12.5 times 60 times 60. And this gives us a value of 2.22 times 10 to the minus 5 hertz. The second part asks you to go on and use some of these values. So first of all, it asks you to calculate the maximum vertical speed of the water. And we know that the equation is that V is equal to plus or minus omega root a squared minus x squared. And we also know that the maximum value is going to be when the displacement is 0, when it's going through its equilibrium position. So that is when x is equal to 0. We don't know omega, but we know that omega is equal to 2 pi f. So this is 2 pi f times the root of a squared, which now is a. We have a value for f. We worked it out in the part before, 2.22 times 10 to the minus 5. And we have a value for a, as we worked it out in B part 1, which is 2.5 metres. Putting all of these numbers into our calculation, we get 3.5 times 10 to the minus 4 metres per second. The third part asks you to write an expression for the depth in metres in terms of the time in seconds. Well, we know that the displacement is equal to a cos 2 pi ft. And we know a lot of these values now. We know that a is 2.5, and we know that f is 2.2 times 10 to the minus 5, and then we multiply it all by t. So our final value for our depth has to start from our undisturbed position, which is 13 plus 2.5, So this gives us 15.5 plus 2.5 cos we multiply out our 2 pi times 2.2 times 10 to the minus 5 to get 1.39 times 10 to the minus 4, and we times that by t. So our final expression is that the depth is equal to 15.5 plus 2.5 cos 1.39 times 10 to the minus 4 t.